Hello and welcome to helpyourmath.com. In this video, we are going to look at characteristics of linear equations, including finding the intercepts, the slope, and graphing. So we're given this equation, 7x minus 14y equals negative 28, and it's written in a special form. I call it standard form. I think some people will call it general form. This is the ideal form for finding the intercepts. So we'll start by finding the intercepts first, and then we'll answer the rest of the questions. If we're going to find an x-intercept, that means we want to plug in 0 for y. So this would give us 7 times x minus 14 times 0, because we're substituting in 0 for y, equals negative 28. This whole thing turns to 0, and subtracting 0 from 7x will just give us 7x. So we get 7x equals negative 28. We divide both sides by 7, and we get x equals negative 4. When I write this out, I like to actually write the entire point. So the entire point is negative 4 is x and 0 was y. And then to find the y-intercept, we'll plug in 0 for x, because a y-intercept is somewhere on the y-axis where all of the x-coordinates are 0. And we'll do that same thing. So we have 7 times 0 minus 14 times y equals minus 28. This first term, 7 times 0 is 0, and we're left with the minus 14y equals negative 28. We'll divide both sides by negative 14. And on both sides, we have a negative divided by a negative. So we're going to end up with positive, and 28 divided by 14 is 2. The y-intercept, we plugged in 0 for x, and we had a y-coordinate of 2. We can either go ahead and graph this line, or we can find the slope. Either way, I'll show both ways, and you can pick which one you like, because since we're finding everything, it doesn't really matter. Okay, so negative 4, 0 is right here, and 0, 2 is up here. And I'll do the best I can to graph this, although the keyboard's kind of in my way a little bit. So let's see, we're going to go kind of like that. It's a little baby line. I'll put the arrows at the ends to represent that it is extending in both directions. Now, I can use the graph to help me find the slope. When we use the graph, we look for rise over run. So starting from one point, I would have to rise 2, and that's a positive 2. And I would run 1, 2, 3, 4. Since I went to the right, that's a positive 4. So in this case, my rise over run will be positive 2 over positive 4, which will simplify to 1/2. So I'm going to say my slope m equals 1/2. Now, I didn't have to use the graph. I could have also rewritten my equation in slope-intercept form. To write it in slope-intercept form, we get y by itself. To start that, I would subtract 7x from both sides. Now, I can't really take away 7x from negative 28 because they're not like terms. And we usually want to put the x term first. So I'm actually going to put the minus 7x first and then minus 28. To get this into true slope-intercept form, oops, that's supposed to say minus 14y. We'll divide both sides by minus 14. We divide everything. There are 3 terms. We divide all 3 terms. And then here we're left with y equals negative 7 divided by negative 14 would make positive 1/2. And then we have that x. And then negative 28 divided by negative 14 would be positive 2. This checks with everything we've already done, right? We said the y-intercept was 2, so that matches. And we found the slope to be 1/2 when we looked at the graph. That also matches. All right, but there's actually one more question. We're not done yet. It says name one point on the graph that's located in quadrant 3. Okay, well up here is quadrant 1, and over here is quadrant 2, down here is quadrant 3, and over here is quadrant 4. So we need one point in quadrant 3. We can't use the intercept because that one lies on the x-axis. And since my graph, I didn't have a straight edge available, so I can actually use the slope to help me. From this point, I can go down 1, that would be negative, and then the negative direction for my run would be to the left. And I can kind of see there's a point right here. That one looks good. So one of the infinitely many points would be negative 6, negative 1. I know it's located in quadrant 3 because both x and y are negative, which is true of any point in quadrant 3. This has been a mega example of linear equations where we looked at intercepts, slopes, graphing, and even the quadrants. And we explored this graph with all of those characteristics about this line. Thank you for stopping by.